Section 2-6, Algebraic Proof. The objectives for this lesson will be to use algebra to write two-column proofs, use properties of equality to write geometric proofs. So our first vocab term is algebraic proof. This is a proof that is made up of a series of algebraic statements. So we're just going to be working with algebra, and we're going to justify each step that we do with it. Alright, so these are the properties that we will use in our algebraic proofs. We have your addition property of equality, which says that if A equals B, then A plus C is equal to B plus C. So if you remember from algebra class, remember when your teachers just say what you do to one side, you have to do to the other side? So that is all this is stating. I am adding the same term to both the left and the right side of my equation. So as long as you do the same thing to both sides, then that equation will still be equal. Same thing when you subtract. The subtraction property of equality says that if you subtract the same term to both sides, then you will still have an equation that is equal. Your multiplication property of equality states the same. Okay, if I have an equation, as long as I multiply both the left side and the right side by the same term, that equation will remain equal. The division property of equality states that I can divide both sides of the equation by the same term as long as that term does not equal 0. So if I can divide both sides by the same term, my equation will still be equal. Okay, we're going to go ahead and skip these. We'll come back to them in a minute. Let's go to this one, the distributive property. And we all know what this is from Algebra 1. So I am allowed to distribute this value and multiply it by everything that's in the parentheses to get this right here. So let's go ahead and apply that to our next example. So for example 1, it says, prove that if negative 5 times x plus 4 is equal to 70, then x is equal to negative 18. Write a justification for each step. So anytime you do a proof, you always want to write your given and then what you're trying to prove. So they told me that negative 5 times x plus 4 is equal to 70. I am trying to prove that x is equal to negative 18. So let's go ahead and do that. So I'm going to start off by writing my problem, and then I'm going to go ahead and justify each step that I do algebraically to solve for x. So the first thing I want to do here is I'm going to distribute this right here. The reason I can distribute the negative 5 is because of the distributive property. So here I would get negative 20 is equal to 70. So my justification for this is the distributive property. Then from here, to solve for x, I can add 20 to both sides of the equation. When I add 20 to both sides of the equation, I get that negative 5x is equal to 90. And the reason I can do that is because of the addition property of equality. I'm going to go ahead and abbreviate some of these so we don't have to write a lot. There we go. So I added 20 to both sides, so therefore my equation is still equal. The last step here to solve for x is to divide both sides by a negative 5. When I do that, I get that x is equal to negative 18. The reason I'm allowed to do that is because of the division property of equality. It says if I divide both sides by the same term, then the equations will still be equal. So here we just proved that x is equal to negative 18 for this equation. I justified each step, and I was able to say why I could get from one step to the other. And so I have shown that x does equal negative 18. Alright, so now let's come back to this these properties right here. For these properties right here, we have the reflexive property, which says that A is equal to A. So, and I know this looks pretty weird, but what that means is if I tell you that something measures 5, you know that it measures 5. It's not going to equal some other random thing. Whatever you have is equal to itself. The symmetric property says that if A equals B, then B equals A. So for example, if I wrote x equals 5, I can also write it as 5 equals x. Doesn't matter which way I write it, it's still equal. The transitive property is if A equals B and B equals C, then A is equal to C. Now this might look a little bit familiar because this looks like the law of syllogism that we covered. Notice how they took out the repeating parts. So if A is equal to B and B is equal to C, well then that means that A should equal C as well. We just have this part right here that's just in the way, but by the transitive property, that means that they're equal. So that right there is what you would say. Substitution property says that if A equals B, then A may be replaced by B in any equation or expression. So on the problem that we just did on example 1, remember how they said that x is equal to negative 18? I can go ahead and substitute and plug that back into the equation that we had negative 5x plus 4 equals 70. I can take this value and plug it back in here because of the substitution property of equality. Alright, so let's go ahead and apply these. We're going to use those properties on example 2. State the property that justifies each statement. So let's take a look here. If 4 plus parentheses negative 5 is equal to negative 1, then x plus 4 plus negative 5 is equal to x minus 1. So notice right here, we have an x on both terms that were not over here. So the property that they used here is the addition property of equality. So we're going to go ahead and write that here. Addition property of equality. On B, if 5 is equal to y, then y is equal to 5. This right here is your symmetric property of equality. So let's go ahead and add one more right here. What if I said, if 5x equals 10 and 10 is equal to 2 times 5, then 5x equals 2 times 5. So what property am I using there? Notice I removed 10 from both of these, and I left with 5x is equal to 2 times 5. So we have this piece, and we cut out the part that repeats. So this right here is your transitive property of equality. All right. Let's go ahead and move on to your vocabulary. We have another term here. This is the two-column proof. This contains statements and reasons organized in 2 columns. So we're going to do a proof. It's not going to be like the paragraph proof that we did. This is another method for proving things. Okay, so you can use paragraph proof or a 2-column proof. So in example 3, it says, if the formula to convert a Fahrenheit temperature to Celsius temperature is this equation, then the formula to convert a Celsius temperature to a Fahrenheit temperature is this. Write a 2-column proof to verify this conjecture. Alright, so we're going to go ahead and draw ourselves here. For a 2-column proof, columns, we're still going to write our given and our proof. Okay, and then on the left side, we write our statements. And on the right side, we have to justify and give our reason. So first, anytime you're proving something, you have to tell me what you know. What do you know is true already? So I know that Celsius is equal to 5/9 times F minus 32. This is given, okay? So this is already stated as fact. So my reason for this is that it's already given. So now I have to go ahead and show that Fahrenheit is equal to 9/5 times Celsius plus 32. So the first thing I'm going to do, and there's more than one way to do this algebra problem, I can multiply both sides of the equation by 9/5. I'm going to go ahead and do that. Notice 5/9 times all of this, and we know that the reciprocal operation the opposite operation for multiplication is to multiply. So I'm going to multiply by the reciprocal, which is 9/5. So I end up with 9/5 C is equal to F minus 32. The reason I can do this is because of the multiplication property of equality. Or sorry, the division property of equality. I'm going to put here POE for property of equality. Now, I divided both sides by 9/5, which is the same thing as multiplying by the reciprocal. So if you don't remember that property from algebra, make sure you remember it. From here, I can go ahead and add 32 to both sides, and I'll get 9/5 C plus 32 is equal to F. The reason I'm allowed to do that is because of the addition property of equality, which says if I add the same term to both sides, then the equations are still equal. Now one more thing, notice the F is on the right side. Here it's on the left side. So I can rewrite this as F equals 9/5 C plus 32 because of the symmetric property of equality, which says that you can flip it. As long as you don't change anything about it, you don't change any of the signs, you can still flip it. So I am done. I have just proved that the equation for Fahrenheit is this right here, and I have justified each of my steps. Okay, so now we're going to go ahead and do some geometric proofs. We're going to be using geometric figures to solve for this. Notice right here, this is the reflexive, symmetric, and transitive property again. And this is just stating that we can also use these with our geometric shapes. So we can still use it with segments, angles, lines, and rays. So we can still use those properties.